It feels great to be here in Cloud9, and actually the cloud is what we'll be talking about for the next 50 minutes. And how cool is it if you have the white stripe doing the introduction for your talk, right? If you notice the year on the video, it's from 2005, and I think when they published this song, they had no clue it was about this presentation today. Right? All right, so in the next 49 minutes or so, I'm going to talk about My Doorbell. And we're all going to think about My Doorbell. And there's actually a fun part to this talk, as there is a serious note in it as well. It's hidden somewhere, and I hope you figure it out by the end of the talk. My name is Bert Ertman. I work at a company called Luminous, and my career has been around Java for the last 20-something years or so. So actually, I've been doing that for the largest part of my life now. That's scary if you think about it. Yeah, I like to do stuff with Java, develop stuff, architect stuff, and then talk about it a lot. So that's exactly what I'm going to do now. So the story for this presentation actually started about half a year, maybe 8-9 months ago, when I was in Las Vegas for the AWS reInvent conference. And not so much that this talk is going to be like a big commercial for Amazon, but it was more like attending that conference, which was impressive by itself. It was like 44,000 attendees. Vegas is impressive, right? Well, you can talk about Vegas. Well, you can think about Vegas, you can't talk about it, right? What happens in Vegas stays in Vegas. So I won't tell you about the conference, but it was impressive. And to me, what sticked was that the cloud, that AWS is all about, obviously, the cloud has gone through this massive rebirth, or actually it's going through that phase right now. Because if you think about it, for the last 5 to 8 years that we are talking about cloud technology, maybe 10 years, if you're a real hipster, right? 10 years, the cloud was a little bit boring, don't you think? It was all about virtualizing infrastructure. Just somebody else's computer at the other end of the internet. And, you know, when you see it for the first time, it's cool, but then after a while, it's not cool anymore. So the whole infrastructure as a service, been there, done that, boring stuff, right? Then we got PaaS, platforms as a service. Platforms, a little bit more interesting, but if you think about it, at the end of the day, it's somebody else running a web server for you, right? So not that interesting either. So what is interesting about the cloud these days, and why is it going through this rebirth? Well, the cloud, as I see it as of now, is becoming this massive black hole, which is trying to suck in all of your data. And that's exactly what the big cloud vendors are actually aiming for. Amazon, Microsoft, Google, all of them, right? They try and gather all your data. And when they succeed in getting your data in there, then the logical next step would be that we also place our logic in the cloud. Because what we have learned from 50-some years of computer science is that you really want to run the logic where the data is, right? It has all sort of advantages. So if they get hold of your data, then the next step is that they get hold of your logic too. So what the cloud is currently becoming is mainframe 2.0. Think about it, right? All the data goes to the other end of the internet. All your logic eventually will go to the other end of the internet. And then we'll do logic and data in the same place, which is effectively a mainframe. So it's mainframe 2.0, but then at the other end of the internet. Well, think about that for a second. So what is the current state of the cloud? And I got this as the main takeaway points which I got from Amazon reInvent. One, and this might seem a little odd, the cloud is becoming more and more about IoT these days. And IoT, as of now, is way beyond, you know, being able to turn on your light bulb with your smartphone, right? It's also about that, but it's way beyond that now. So IoT for cloud vendors is all about gathering data, right? Because if we have sensors and smart things all over the place, then they send events and data all the time. And so where do you keep that data? Well, you keep it where you have elastic data storage, which is usually the cloud, right? So vendors like Amazon, Microsoft, Google, they're investing in this space because they want to be the gateway for your IoT devices and sensors. So they are tracking all your data, gathering all the data, so you get this huge collection of big data. And so the next step, what is happening in the cloud right now, and all the major players are really big into this, they're into artificial intelligence and machine learning. Well, who isn't these days, right? But cloud vendors are specifically into this. And this offers benefits because Amazon offers you like a pre-configured machine learning AI environment that saves you all the trouble of setting up machines, setting up all the software, training models, etc. So they provide you managed services where you can start doing machine learning in like under 10 minutes, right? So, and they want to attract developers to their cloud because if you gather the data there, you might want to run intelligence on that big lump of data. Because making sense of millions of sensor events can't probably be done with just regular data processing. So you want to run some smart algorithms on top of it. Maybe AI, maybe machine learning. And we're trying to filter the big hump of data and try to get the interesting bits out of it. And so when we have the interesting bits, then the next thing is you want to do something that makes sense with those interesting bits. So if you find something interesting which is happening in your IoT devices, right, you filter it out using machine learning and then you fire it off to some serverless function somewhere, which is also running in the cloud, right, because you run the logic close to the data. So that's why Amazon is really big with their Lambda platform, their functions as a service platform. And you see the same with Microsoft and Google and some of the other vendors, right? They all invest heavily into serverless. And whether you think it's a hype or not, that doesn't really matter because this is going to stick for a while. So better look at it now that it's becoming popular and still plenty of time to play around with it when it's in its infancy. Right? So Lambda makes sense. It's an event-driven platform, so when you find something interesting, you fire off an event, then your Lambda comes into play, does something interesting with that piece of data, and this is how the mechanics of Cloud 2.0 are actually working. And then there was a fourth trend as well. Might seem completely unrelated to the previous three, but this is the whole hype of the no interface thing. I don't know if you have a voice assistant at home, maybe on your phone, like Siri or something from Google or whatever. I brought my Amazon Alexa device, which I will put to use later on in the presentation. So lots of people have either the Amazon device or they have the Google Home or they have something similar, right, from Apple or from Microsoft or whatever, or what have you. And this whole thing of no interface or voice assistance is really making a comeback. So I remember playing with voice back in the Windows 95 days, where I had to train my model for hours and hours and hours to get used to my voice. And then finally, after hours of training, I was able to maybe shut down Windows with my voice or something like that, right? So it wasn't that exciting back in the days. But then somehow, we never thought about applying voice technology again. And then, like a few years ago, companies like Amazon and Microsoft and Google, they heavily invested into this voice assistant capability. And now they give us this hype of no interface. And what no interface means is, why can we only input stuff into a computer using a keyboard and a mouse? That's actually a stupid idea, right? But we still hold on to that idea. But what we do most is probably talk, right? So we talk to each other. Why can't we talk to the computer, right? Like they do in Star Trek. And Star Trek, as you know, is probably the biggest source of inspiration for companies like Amazon, right? They just try to recreate what was in series like Star Trek. Right? So no interface is becoming a hype, and no interface can already be put to use for production applications. There's lots of interesting releases around no interface and voice assistants coming in the next couple months, couple years. So this is definitely also a trend which is related to the cloud, and I'll show you later on how that is. So the cool thing about the cloud these days is that it's no longer just about infrastructure and it's about platforms as a service or containers or whatever, but the cloud is becoming this big pile of ready-to-use building blocks. If you go watch the keynote from reInvent, you will notice that they no longer speak about developers, but they talk about builders. So what they are looking for, they call their users builders, right? So they want you to pick up the Lego pieces and then create something. And they even claim that without a lot of developer knowledge, you are still able to put together cool stuff in their cloud using the building blocks that they make available. And it's not just an Amazon pitch, it's also the same if you go to a recent Microsoft conference where they talk about Azure, or if you go to Google I/O where they talk about the newest service in Google Cloud. Right? It's the same thing. So think of the cloud as a huge pile of Lego pieces that you can use from your toolbox to put together some really cool applications of technology. So when I was thinking about this, when I flew back home in the plane, I thought, well, I want to do a talk about this, and I want to do a cool demo. And as we know, the demo these days, the demo standard these days is a to-do application. And you probably saw a couple of those today already, right? I saw one at Simon's talk this morning, and there were probably more. So the to-do application is the current standard for demos. But you probably believe that I can do a to-do application in the cloud, right? It's not really sexy, so I want to do something else. So while I was thinking about this, I was in my living room, sitting on my couch, and then somebody rang my doorbell. And so I thought this is divine intervention, right? So somebody's trying to tell me that I should use my doorbell as the example for this cloud talk. So that's exactly what I did. So this is how I came to the idea. So I started thinking about this, pondering it really hard. So what can I do? Started Googling, and I found pictures like this. And this is like the cloud-connected, cool, geeky doorbell. You can buy one from eBay for about 200, 250 bucks, right? But it's, of course, way cooler to not buy it off eBay, but create it yourself, right? And so that's exactly what this is the journey I started on. So Google some more. I found even cooler doorbells, right? Then I found this one. That one got me really excited. So yeah, this is where this was going. Then I have to make a small confession here, because I have these kind of ideas more often, and then I noticed over the years of all the experience that I gathered that there's a slight discrepancy between the things that I think of and reality, right? And I can best sum it up using pictures like this. So this is more like it, right? So I have this insane idea, and then in the end, turns out a little different. So it was the same actually last Christmas when I tried to take a picture of my youngest daughter. That didn't really work out. When I tried to make her a cake for the birthday, not really a big success. Year after, tried again, nah. Then I tried to make an omelette for my wife for the birthday. That almost got me into a marriage crisis. And then try to make cookies for my kids. No, didn't really work out. So you probably get the message, right? This is a very long disclaimer that by the end of this talk, the demo might be a little bit disappointing. All right. So just to make it worse, when it comes to home automation and IoT projects, I'm the kind of guy that has all the smart light bulbs at home. And so, I think like half a year or 3/4 of a year ago, I had this really cool idea. I have the smart light bulbs from Philips, and I wanted to make them flash red for like 10 seconds every time my favorite team scored a goal in this season, right? Now, as my favorite team became the season's champions, they scored lots of goals Friday, Saturday, Sunday. So whenever they were playing, right, I hooked the light bulbs up to their Twitter feed, and every time they score a goal somewhere, then their Twitter feed says, goal, goal, goal. So that was really easy to parse, right? So every time they tweeted about that they created the goal, the lights in my entire house started to flash red for 10 seconds. So it worked. I think it was a great application of, IoT application, right? It's really cool. Then it drove my wife and kids a little bit crazy. So usually, the kind of, home automation project that I do tend to end up worse than before I started. All right, now let's think about this doorbell project. Let's pretend nothing happened, and let's think about this doorbell project. So let's start off with, we always start off with the user story, right? So here we go. As a nerd, I want to detect who's in front of my door so that I know who is there. And then I want to go one step further. I also want to detect the kind of emotions that the person shows, right? Because if there's someone that I don't know at the door, and he's looking really angry, and I probably don't want to open the door, maybe. So I think, well, actually, pretty cool use case. But then, with the whole flashing lights in mind, my wife got word of my newest idea, and she sent me a very clear message, which was something like, don't touch the doorbell, right? Something like that. But she made it very clear. So yeah, so there was this, already my dream started shattering, right? Because smart doorbell, you just saw the picture, and now all I have is this dumb doorbell. Here we go again. Dumb doorbell. Although the good news is, you can actually build a smart doorbell from a dumb doorbell without even touching your door, right? And I figured out how to do it, and I just want to share it with you. So how do you start, right? How do you start with a IoT project? I had no idea. And then somebody said to me, well, in IoT these days, if you don't know how to start, then you start with a Raspberry Pi, right? Doesn't matter what you do, just buy a Raspberry Pi, and then from there everything goes down, probably downhill, but okay. So that's actually what I did. So I had a bunch of Raspberry Pi lying around. I had this, well, then the latest model, Model 3, with the whole starter kit. So it had like a case, HDMI cable, power supply, pre-configured operating system, really easy. And then there's this other handicap of me, which is when I go to a conference and I go to a talk like this, where somebody is showing off some cool device or something, and then there's like a stand at the pavilion selling this stuff, I always buy it, right? Just take my money, I'll buy it. So I buy lots of stuff. So I had this camera lying around as well. I think it's 3 years old, never touched it, bought it at a DevOps conference probably, then went home, put it on top of the pile of other stuff which I buy at conferences, never touched it. So in this case, it really came in handy, right? And creating the camera for my doorbell is actually pretty easy now, because you just hook the camera into your Raspberry Pi. It is pre-configured, so you plug in the memory card, plug it into the power supply, and the only thing you have to do is update everything, which is easy to do. Then you open up the configuration to enable the camera, quite an essential step. And if you have enabled the camera, you can just use the built-in raspi still command, which can just snap an image and then save it to disk. So this is actually a pretty good use case for my smart doorbell. So step 1 of my doorbell project was already finished, right? Just a couple minutes of work. The next thing that I wanted to do is build some microservice. I had no particular reason, but mostly because microservices are cool these days. And I wanted to snap a picture using the Pi camera. And the only thing that this service needed to do was just snap the picture. So do one thing well. Sounds like a microservice, so it probably is a microservice. Now, for this microservice, I needed a Java library, because I'm a Java guy. So I needed a Java library, and I found one on GitHub. It's called JRPCam. Right? It's a cool library, and basically it's like a Java wrapper around the raspi still command, which I just showed you on the previous slide. And you could do some cool, settings and fiddling with the camera settings, the light settings, exposure stuff, etc. So it's a really cool library with a nice builder object that you can use in order to configure the camera and then eventually take a still picture or record a piece of video. The other thing that I needed is some sort of a microservices framework, right? Because I want to expose this web service on this small web server, but I didn't want to install a web server and everything that goes along with it. I just wanted to run something from the command line, like a runnable jar file. So, well, there's plenty of microservices frameworks to choose from. I chose a very lightweight one, which is Spark Java. Highly recommend it. It's a really easy to use framework. As you can see from the code example, it's just taking advantage of closures in Java, and you just have like a simple get operation with a single line of code. Right? It's really easy to use. So wrapping the JRPCam libraries with the Spark Java framework and like a couple of lines of my own code yields you about a 2 megabyte jar file, which suits the microservices definition, I guess. So just to give you a glimpse of the code which I wrote for my microservice, on the top of the screen you see the get route, right, which is basically a HTTP GET mapping. And then what I'm doing is I'm initializing the camera, tweaking a little bit, the settings to make the image not that big, so it's easier to transmit to somewhere else, right? And set the exposure to night mode, so it's also taking shots in low light conditions. And I set a timeout of about a second, so it can get used to the light conditions and then automatically figure out some other settings and snap the picture. And it works out really well. And then I'm gathering it as a buffered image, and then using some of the low-level servlet classes, I'm converting it into a byte array output stream, and then stream some bytes back to the one doing the get call, which could be a browser or something else. So it's really, really simple implementation, actually. Just a few lines of code, right? So this is a microservice. Then wrap it up as a runnable jar and run it from the command line. There we go. Second problem now also solved. So what would be the logical next step? Well, obviously, if I snap a picture with the camera, I want to detect if there's a person in the picture, right? Because that's where the whole recognition thing will start. So I need face detection, right? So just snap a picture, and then save that picture somewhere, and then ask something if there's a face in the picture. Now, if you think about it, I want to do a talk about cloud, and not so much about Raspberry Pis. So I don't want to do the heavy lifting on the Pi. I want to do the heavy lifting in the cloud, right? So heavy lifting goes there. So I need something in the cloud which is able to recognize faces in images, and then also do detection of that face, or not only detect it, but also try to match it against maybe a list of known faces. So Amazon, what have you got from me there? Well, Amazon has this cool building block called recognition, with a K. And recognition is a really nice building block because it can do both object and scene detection, so you can feed it any image, and it starts recognizing objects in the image. Not only faces, but also other things. But you can limit it to just faces. Then if it finds a face, it can do analysis on the face. Right? So it can say, well, it's smiling, or the face looks happy, or it looks sad, or surprised. Right? It can also say with confidence whether it's a male or female, whether it's wearing sunglasses, whether the face has a beard or a mustache, etc. Right? So there's all sorts of detection on the face going on. And then finally, it's able to compare faces. So if it has like a pre-trained model of some photos of a given person, it is able to match a new photo of that person against the pre-trained model, and it can detect whether that particular person is in the picture. So that's exactly what I need. Right? So in order to play around with this, I need the Amazon command line interface, so that's also very easy to install. Just a matter of getting the CLI zip bundle, unzipping it, installing the command, and now I can just run stuff locally from my computer or from the Raspberry Pi against the service in the Amazon cloud. So it's really easy to get started. In order to build up a collection of faces from pictures, I need to have two things. I need to have a so-called collection of, in this case, my friends, which I want to recognize. And then I need to have a so-called bucket, which you can see as a database in the cloud somewhere, which will hold all of the images which I upload to the cloud, and which I then run through recognition in order to do detection. Right? So in order to create this, you say, well, create a collection of so-called friends in the recognition building block. So all of the people which I tag as a friend, they go in there. And before I'm able to do any recognition, I need to have a S3 bucket, a simple storage service, which will hold all of the images. So then I can refer to those images to recognition, so it can then take the image and run it through the recognition software. So then I created a couple scripts. One is called upload friend, and this one takes two parameters. The first parameter is an image file, and the second parameter is the name of the particular person on the image. So I'm actually training the model here. So I'm taking a picture of myself, for example, as the first document, and then I say, well, this is Bert, and then I can run it through this script, which will then upload it into the S3 bucket, and then ask recognition to index the person in the picture with the tag Bert. So from now on, I will be recognized, hopefully. If I upload subsequent photos to recognition, it will start to recognize me. So I can train the model by sending it pictures and tagging them. And I found out while doing this that it's actually pretty advanced. So you just need one or two pictures of someone, and then it will recognize a whole lot of faces from other pictures. So it's actually really, really good. So the script at the bottom is called find friend. And what this does is I can give it another image, which may or may not have one of my friends in it, and it will upload that into S3 and then trigger recognition, and then ask recognition, are there any persons in this picture? And if there are, match them against my friends, and if you have a hit, well, report it to me. Right? So now I can start detecting my friends and people that I know from the pictures which I upload. So to just give you a visual clue how this works, let's take a picture. This is my oldest daughter, and I can upload that into S3, run it through recognition, and then tag her as a friend. Right? So now Amber is in the friends collection, and then whenever I take another picture, maybe this one, this was taken like 3 years before the other one, right? I can then use the other script with the find friend in it, and then upload that into S3, and then ask recognition, is there anyone in this picture that you recognize? And then if Amber is the only which was trained, the recognition will say, well, I recognize two persons in this picture, and the one on the right is Amber, with a certain confidence. Right? And if I train Bert as well, then recognition will recognize both of them. Okay? So this is how it works. So actually, pretty fun, a couple scripts, couple lines of code on the command line, and I already had image recognition and detection working. So now, the thing is, if I will detect persons in the image, right, how can I run any logic? right? Where do I actually run this image detection logic? So we're using the recognition building block, but I also want to write some logic around it, because I want to know if it's someone that I know, then it will call out the name. If it's not something that I know, I want to know if it's a man or if it's a woman and what kind of emotions the person showed. So I need a little bit of logic. So how do I deal with logic? And I was not really in the mood of setting up a PaaS platform on Amazon Cloud. Not go through Beanstalk and set up web servers and deal with web servers and patch web servers and then whatever kind of infrastructure that I need. So I wanted to be as serverless as possible. So I remembered this quote where Werner Vogels from Amazon said, well, no server is easier to manage than no server at all. And this is, of course, absolutely true. And this is what sparked off the whole hype of what we call serverless these days. So Amazon and other cloud providers, they are offering you this serverless platform. In the case of Amazon, it's called Lambda. This was announced in 2014, so it's a while back. And so the platform has got quite mature nowadays. And this is an event-driven platform where whenever some events happen, you can hook those events up to so-called functions. And then your function will run with the event as input. So whenever I have this picture and I detect a face, I can take that face as input for my Lambda and then do something useful with it. Right? So this is a very powerful programming paradigm, which is broadly available at different cloud providers these days. And this is one of the tools that I think every one of us should have in our toolbox, because you don't want to convert all your applications into functions these days, but functions can be a really interesting programming model for some use cases. So how does it work? Well, you create a piece of code. I will just show you an example in a second with just a function in it, or a class with a function in it. Function takes something as input, does something interesting, and then has some output. Right? I create a zip file out of this, upload that into the cloud, and then I define a trigger for that function. So, for example, the trigger could be I send an email to it, or the trigger could be I send an HTTP GET call to it, or the trigger could be I find a face, I detect a face which I recognize, and then trigger my Lambda function. The function just sits there with the event it takes as input, and when nobody ever triggers it, I will never pay any cent for having this Lambda function available. It's totally free. But as soon as somebody actually trigger my functions, then Amazon will start to meter it, right, for just the runtime of that particular function, and then send me a bill afterwards. So I'm just being billed for the number of milliseconds and a little bit for the amount of memory that I use, and that's the only bill that I will get. So this is the true pay-as-you-go model, right? So if you use it a lot, you pay more. If you use it just a tiny amount, or if you use it not at all, you never pay for it. So this is the true meaning of pay-as-you-go. So it's actually a pretty cool model. So I was thinking about having fun with Lambdas in the cloud. So I thought of this use case just to get a feel for how this works. I created two Lambda functions. The first one, the top left-hand side, is a Lambda function which takes a search term as input and then heads out to the Flickr API and then searches for the 10 most recent images that match the given search term. And then when it finds those 10 images, it uploads them into an S3 bucket. And this is my input bucket. And then on that bucket, I created an object created trigger. So for every new object which is inserted in the bucket, I fire off an event to my second Lambda function. And this Lambda function runs the image through recognition. And it tries to recognize if there's one or more faces in the picture. And then if it finds faces, it will tag that image as that it has found faces and then save it into another S3 bucket. So not a real use case for My Doorbell, but just to get a feel for how this whole Lambda and image recognition thing works. Right, so I'll just show you a little bit of the code. Here's a Lambda function. Just basically it's one Java function, one Java method called handle request. You see it takes a search term as input, and then it has some string as output, and then you have the entire function for you just to write some business logic. So in this case, I wrote a business logic that say, well, download some photos from Flickr using a few lines and the Flickr API for that particular search term. And then for each photo that I got back, I just upload the photo to S3, to my incoming bucket, and this does exactly what you think it does. Right? Then the second lambda is processing the recognition and save the result. So a little bit more code. So let me zoom in the interesting part. Once again, it's also in the handle request method, but only this time it takes an S3 event as input. So whenever somebody inserts something in S3, it will trigger my function. And then I get the event as input. So I figure out the bucket and key combination, which is like the table and primary key, if you want to compare it to relational databases, to figure out where the image is, and then load that image and pass it on to recognition, and then start to detect faces. And then for every face that I detect in that particular image, I print some details to the log, and I try to draw this bounding box around the face in the image, based on the coordinates that I get back from recognition. Right? And then I save the end result with the bounding box on top of it in another S3 bucket. So let me show you what this looks like. So for this, I go to S3 first. So this is the S3 management console. Let me refresh it. Right. So there's a bunch of buckets in here, but one of them is the My Recognition demo bucket, which is currently empty. Right. So I have nothing up my sleeves. It's an empty bucket. And then I can go back and show you the other bucket, which is the detected faces bucket, also empty. So currently everything's empty. Now I can go back to my Lambda console and look at the bunch of functions which I have created. And one of them is the Flickr search Lambda. If I open this up, then I have the Lambda over here with access to S3, so it can upload some images in there. And then I can test it by inputting a test event. So in this case, I'm going to search for portrait. Okay. So now when I press test here, this Lambda will head out to the Flickr API and try and download the latest 10 images which are tagged with portrait. Takes a little bit of downloading the high-res images and then putting them into the S3 bucket. And hopefully, if the internet and demo gods are with me, this works. Got to be patient here. Yes, so the result seemed to be positive. So as you can see from the logs, it downloaded a bunch of images in the S3 bucket. So now if we go back to S3, and we go to the incoming bucket over here, the recognition demo bucket, there should be images in there. It's a cloud. It's eventually consistent. There we go. Right. So there's a bunch of images. Okay. And now while they were being downloaded, right, for every time I upload one in this bucket, S3 will send an event to my second Lambda, which is in the Lambda console. Here we go. In my functions console, which is called the face recognition Lambda. And this one, as you can see, has an S3 event as input. So now it's good. On the bottom over here, you see that on the My Recognition demo bucket, there is a trigger called object created by put. So whenever somebody inserts a new object, it will trigger my Lambda. So this has been run as well. So if I go to the S3 management console, go back to the other buckets, then hopefully in a detected faces bucket, when I refresh, there's a bunch of faces. So apparently it's either still running or no, it only detected a couple faces. Well, sometimes people tag photos on Flickr with all kinds of funny tags, so you have no idea whether there's actually faces in there. So apparently only 2 had faces. Now this is the trickiest part of my presentation, because I have no idea what I downloaded. So I'm going to ask you to close your eyes, because there's a code of conduct at this conference, right? I don't want to violate it. So close your eyes. I'm going to see if it's safe. And then I'm scared. Okay, well, you can open your eyes. It's okay. It's okay. Whew. Okay. All right, so it got a photo of Flickr, and then it ran it through recognition, found out the coordinates for the face, and then drew the bounding box, right? So it was just a way of toying around with lambdas and with detecting actual faces and do something useful with them, like saving them as another picture. All right, so let's get rid of this, and let's get back to my mission. My mission was the smart camera, right? So next challenges. How do I actually trigger the capturing of the image? Because I have not actually a smart doorbell, but a dumb doorbell. So just the analog doorbell, somebody presses it, and then I want to snap a picture. So I thought of several things. First one was just detect movement. Right? I can just put something on the Raspberry Pi that detects movement, and when it detects movement, it just snaps the picture and uploads it into S3. That could be a cool way of doing this. But the problem is, I live across from a school. So there's lots of movement in front of my door. So that didn't really work out, because I was just quickly filling up S3, and one day I got a phone call from Amazon, stop, you're ruining S3. So I stopped doing that. Okay. So then the logical next step is to snap the picture on demand. But then how do I expose the Raspberry Pi to Amazon, right? So something within Amazon can just ask my doorbell to snap the picture. This is tricky, because if you just open up your house network to the outside internet, right, probably won't take long before you have Chinese botnets running in your house. That's probably not a good idea. The other problem that I had was, how do I visualize the response? So I know how to snap a picture, I know how to detect, the faces, but how do I visualize the response? And if I go out to Alibaba and buy some really cheap LCD display and then mount it on my wall somewhere, and so whenever somebody rings the doorbell, I can just walk through the LCD display and then look who's in front of the door, and it doesn't make sense to do automatic image recognition, right? Because I'm the one doing the image recognition. So that doesn't work out. And the same problem is with all of these smart doorbells from the internet, because they snap a picture and then send it to your phone. Right? And then your phone buzzes, and you take out your phone and you do the recognition of the person. Right? So I didn't want to do that. I wanted to have the intelligence in the cloud, and then somebody has to alert me who was in front of the door. So once again, sat down on my couch, right? And somebody rang the doorbell, and then it struck me. So whenever it doesn't make sense to see who's in front of the door if I'm not home, right? It only makes sense if I'm, lying on the couch, somebody rings the doorbell, and then I ask my wife, hey, who's in front of the door, right? So I thought, well, if I can ask my wife, I can also ask, my other wife, Alexa in this case. And I can say, well, Alexa, who is at the door, right? So this is a perfect use case for this whole no interface thing, because you're lying on the couch and you want to know if it makes sense to get up, walk to the door, and whether there's some annoying salesman over there, or whether it's one of your friends coming over, right? So the audible trigger is actually my trigger as a human to then ask Alexa to figure out who's at the door. And then Alexa can hopefully call out to my Raspberry Pi, get the image, run it through recognition, and then give me a voice response who's in front of the door. That was the idea. Now, luckily for me, I found out that Alexa has a way to actually trigger Lambda functions. So I could use my fun Lambda functions for my Flickr experiment, and then do a little bit of different stuff in there, and then hook them up to a so-called Alexa skill. And then whenever I issue a voice command to Alexa, I can translate that command into a trigger, an event, which will then trigger my Lambda function, which will go out to the Raspberry Pi, snap the picture, take that picture to recognition, and then tell me who's in front of the door. So a trigger for, or actually Alexa triggering your Lambda function is something which looks like this. So instead of writing a Lambda function, you now have to write a so-called speechlet. And this is a little bit like a servlet in the old days. And so you have a function like this, which is called a get doorbell response. And then what I'm actually doing is when I trigger this Lambda function, I want this code to go out to my Raspberry Pi, snap the picture, upload it into S3, then do the recognition part, and then give me an audible response. So that's basically hidden in the function that you see over there. And then at the end of this code, you see that I'm creating a so-called simple card. And this is basically like a text version of the spoken response, which goes to the Alexa app that you have on your phone. Or if you have a more fancy Echo device, not the one that I'm having here, but the one with the display, then it will display that card on the screen of that Echo device. So you also have, textual response. And then you have the spoken output, which in this case is a plain text output speech. So I can just construct a Java string. I can send that as a plain text output speech, and then Alexa will give me an answer with the contents of that speech object. So it's actually pretty simple to build this, just a few lines of code. So now I had this Lambda function calling out to my Raspberry Pi, but then I had no way yet of exposing the Raspberry Pi to the cloud. right? Without opening up my firewall for the entire internet. So while I was looking for solutions, I stumbled upon this cool thing called local tunnel. Don't know if you know it, otherwise you know it now. And local tunnel is a way of just taking just a server somewhere, maybe hidden in your home network, and then on the local host, just expose a single endpoint to a well-known server on the internet. So basically I'm using an intermediate service here. So I open a tunnel from my Raspberry Pi to a service on the internet, the local tunnel service. And then somebody else, in this case my Lambda function, can call out to that well-known endpoint at local tunnel, which then goes back to my microservice running on the Pi. Right? So it's actually pretty cool. It seems quite safe, right? Because you can use API keys and stuff in order to secure this. And it also works great for conferences, because when I go to conferences and take my Raspberry Pi and whatever, I probably am not in a position to mess around with router settings and whatever, or mess with the firewalls. So this is like a pretty safe setup for conferences as well. So let's hope it works. So now I've got all pieces of the puzzle, and I can go into the last phase of every good software development project, which is the hooking shit together phase. Right? And so now I have the input device where I can issue a command to, which will then trigger my Alexa skill, which fires an event. If it recognizes the command, it will fire an event to my Lambda function, which heads out to that well-known endpoint at local tunnel, which calls into my microservice, snaps the picture, uploads that to S3, and then triggers recognition on it, and then a text response goes back to the Alexa skill, which will then hopefully give me a spoken response who's in front of the door. So that's basically how it works. Somebody presses the doorbell. It's me sitting on the couch here. Actually, it's me sitting on the couch here. And then I just ask Alexa who's at the door. Right? So now it's demo time. So I hope I have sacrificed enough sandwiches at lunch to the demo gods. So let's get this one off mute. Right? And so here we go. Alexa, ask doorbell who's in front of the door. Takes a little bit of time to fire everything up. I'm standing in front of the camera now. And hopefully, the internet is with me. Hopefully, I said. Building up suspense here. More suspense. Give it a few seconds. First time is always, well, it's a demo, right? So
there was a problem with the requested skills response.
Okay, well, at least it's giving me a spoken response, but not the one that I want. Let's try it again. Alexa, ask doorbell who's at the door. It's the retry pattern, right? Still, I don't see anything happening, so that's not good news. So let's see if something is wrong with the service over here. I think it's okay, but no, it's taking too long. Go off the internet, get off the internet.
There was a problem with the requested skills response.
Maybe stop watching Netflix, that helps maybe. Let me see if something is wrong with my tunnel. Let's try it again. Sometimes the firewall might be blocking it. This could be a problem. Bear with me for a second. It's not working yet. Let's see what the problem is. My URL is taken somehow. Oops, there we go. Let me try it again. Nope, somebody has somehow taken my endpoint, so that's a little bit of a pity. So that's okay. I'm going to fix this. I'm going to fix this by trying to solve this on stage. It's probably not a good idea. But now you get to see the internals of the service, which is a good part. Okay, so I have my doorbell server. That one is all right. So I go to the doorbell Alexa skill. And somewhere in there is the well-known endpoint. So let's call this one JSpring doorbell. Let's save this. And then upload it into AWS. That looks about right, so upload that. So the speed of the internet seems to be okay. So now I have updated the Lambda function, which Alexa will call into. Oh, I shouldn't say that when she's on. Now I got to fix the endpoints. So let's see, what's it doing? I'm going to do a LT minus port. JSpring doorbell. I think this works. Hopefully, yes. And so the next thing is to run the server. Actually, my microservice. So hopefully now everything's hooked up correctly. And I can try again. Here we go. Alexa, ask doorbell who's at the door.
I found a few matches. Do you mean the Grand Tour quotes or Grand Tour quotes?
I don't think so. I don't think so, Alexa. Stop. Alexa, ask doorbell who is at the door. There we go.
Bert is at the door, and he looks sad.
Okay. Okay. That worked. Okay, that's cool. So apparently I forgot to offer one sandwich or so to the demo god. So okay, we got it fixed now. So let me try something else. Right? So I have a picture of my daughter on my phone. So I'm going to do the demo again and try if my doorbell will recognize my daughter. Right? So Alexa, ask doorbell who's at the door.
Amber is at the door, and she looks happy.
Okay, that works. So let me try another one. This one, is it? Okay. Alexa, ask doorbell who's at the door.
An angry woman is at the door, but I have no idea who it is.
Okay. Now let's try one more because we're almost out of time. Let's try this guy over here. Okay. Alexa, ask doorbell who's there.
There is a very scary man at the door. If I were you, I would get the hell out of here.
Okay. Okay, so this works. Cool. So now I can officially say that I nailed it, right? So instead of this fancy doorbell that you can buy from eBay, there's actually stuff that you can do yourself, which will end up with an even better result, in my opinion, at least. So let's talk about costs here, right? So buying the doorbell from eBay is about $200, and then doing this yourself is about the same amount of money. So it takes a Raspberry Pi starter kit, which is 60, 70 euros maybe. Maybe you have one lying around. Then you need a camera. If you use the official one, it's about 20, 25 euros. But you can also go to Alibaba and buy a cheap Chinese knockoff version of the original camera, only $5, so that's probably better. And then you need an Amazon Echo device. I have the fancy Echo V1 here, but there's the Echo Dot, which is much smaller. It's also much cheaper. I think it's available in the Netherlands as well, the international version, although I do not recommend buying that one because it lacks some features like Spotify integration and some other cool stuff that you can't do with it. So I recommend getting the US version, or maybe a similar device like from Google or whatever. So the US version is also available at some shops in the Netherlands. It costs you about 70 euros. If you want to have this one with the bigger speakers, I think it's about 120 euros or so. And they have new ones with displays as well. So actually really cool to play around with those. And then there's also variable costs, because if you hook some stuff up in the cloud, you're going to pay for that cloud stuff as well, but it's pay as you go. So I've been using a little bit of storage, some Lambda functions, object recognition, and then CloudWatch for logging. And I did some crazy demos, pulling lots of images from Flickr, etc., and I never managed to get past 1 cent per month, right? Because there's lots of free tiers. So the first 1,000 pictures are for free. The first 1,000,000 Lambda functions are for free every month, right? So you have to get a pretty crazy doorbell if you get over that threshold, right? So for about 160 euros, so for about $200, right, you have the same thing, but then even better, right? And of course, you get to play around with all these cool cloud things. So that's probably the serious part for this talk. It's the final slide. And well, in my opinion, that was the reason for doing this talk. I think the cloud is in a really interesting rebirth process. And maybe the cloud is not really influencing your work right now, but that will change in a few years. So these new technologies that are out there in the cloud, like serverless and Lambdas and all of the building blocks that I just talked about, they are real, they are out there, you can really use them. They're pretty advanced, way more advanced than My Doorbell. So there was a recent article about 2 weeks ago about some people complaining that the recognition software from Amazon is so good that they also give it to the government, like the NSA and the CIA are their biggest clients, right? And they also run this recognition software. And it's so good, it's able to pick out thousands of faces from crowds at the same time. So actually pretty advanced stuff. And the first 1,000 operations are for free, right? So it's really cool to build some cool stuff with it yourself. So I highly recommend to experiment with this kind of stuff, right? If you sign up for a free tier at Amazon, you get most of their services for free for about a year. And Microsoft, Google, they have similar offerings, and they have also similar building blocks. So it's really cool to play around with this stuff, get this knowledge into your developer toolbox, and know how to apply it. Because if you won't do it, then probably your competitor will start to use these kind of features, and that will give them like a really cool head start. And especially things like serverless and everything that's around it in the ecosystem, you might still think it's a hype. You might still think it's, triggers reinvented, database triggers reinvented, right? It probably is, but it's becoming really, really useful and really advanced. So I highly recommend checking it out and making it part of your developer toolbox. All right, so with that, we're out of time. So I'd like to thank you for your attention. Goodbye.